Hello everyone, so today we are going through Leetcode daily challenge number of 1 bit. So basically in this question we are given with 32-bit number. So what we are required to do is we are required to count all the ones which are present in this number which is being given to us. So basically after the question, we are required to write a function that takes an unsigned integer and returns a number of 1 bit it has, also known as Hamming weight. So here the thing is that know that in some languages such as Java, there is no unsigned integer type. In this case, the input will be given as signed integer type. So it should not affect the implementation. So in all these contexts, we are required to have a solution in which we can directly have something which doesn't affect these complement thing, uses two complement notation and even this unsigned and signed integer. So our implementation should be something like that. So now before going ahead, let us check for a constraint. So the constraint here is that we are given a binary string of length 32. That is the only constraint which is given to us. So we need to work upon this thing. Now, let us start with the approaches of this question. So there could be two approaches. First approach could be which is intuitive in nature, because what we can do is like whatever number we are given with, we'll directly count single bits which are there, right? And we will simply add up to our answer. This is what we can do. And how we can do that? We can do by first what we can do is like in numbers what we do means whenever we are given with any number we do modulo, right? Modulo with 10 or anything like that. So we do modulo, and after doing that modulo we can get the last number which is being with us, right? So like this only we'll first do the modulo, and second thing which we'll do is we'll directly shift it towards the right? So that whatever number we are having at this position, it will shift towards this position. So in that context, we will be getting all the ones which are being present in this particular number. So this is the first and most intuitive approach which we can get. And the second approach is this one, in which we would be required to do sum plus equals to 1, and then we would be required to do and the second approach is here we'll first do like this, and then we'll assign n and n minus 1 equals to n. So before explaining, and this will do until n equals to 0. So before doing all this, let me give you one example so that we could better understand this approach. So if we are given with this particular number 100 means 32 bits are there. It is a 32-bit number, that's why I put dot between. So this is a number, and when we do minus 1 from this, then it becomes something like this, right? And when we do AND with it, so 1 and 0 would be 0, 0, 0 would be 0, like this, everything would be 0 here, and 1 and 1 would be 1. So the new number would be this, means 1, and all other bits would be set as 0. So this is what a new n would be. But before doing all this, we have done this sum plus equals to 1, right? So our result would be here as 1. Now here, before then our new n would be this. So before moving ahead, means before doing this particular operation, what we'll do, we'll increment our result again. So now it will become result equals to 2 at this particular moment, right? So now what we will be doing is we'll again do n minus 1, which is this one. So when we do minus 1, so all the bits which are 0 here, they will turn into 1, and the one which was there, it will turn to 0, and when we do AND it, then it will turn out to be as 0. Now n has become 0, so this is the condition which it has reached. So now it will simply exit the loop, and at the end, as there were only two ones, right? Means one was this one and one was this one, and the result was also incremented two times, right? So our answer here would be 2, right? So by this bit trickier part, we were able to come up with this particular solution. But the more intuitive one is this one. Although both are having same time complexity only, because time complexity here would be order of 32 only. Why order of 32? Because we are required to traverse this whole bits which are 32 in size, means there are 32 bits here, so and we are required to traverse whole of them. So that's why it would be order of 32, and the space complexity here would be order of 1 only, because we are not using any extra space, we are just manipulating the bits which we are given to us. And here also the time complexity is same as 32 only, because at the worst scenario we could do 32 time also, but the thing is, and the space complexity is also order of 1. But now the thing is, this is much more faster than this particular approach, means from this approach is much faster, because of the fact when we are doing AND. So here at two steps only it was able to give us the solution, but in this particular approach, means this one, it was not able to give up in this two step, even if the number of bits were 2 only. We were required to traverse the whole bits which are given to us. So that's why somehow for improving the time in context of, although both are having same time complexity, but still for getting more fast results, we could use this second approach. Now let me walk you through the coding part. So here is for the first one. So here this is for the first solution. For the first solution, the way I told that we would be required to have a result there, and we will be doing by until it becomes equals to 0, right? So first thing which we were doing was in percentage 2. Why we are doing by 2? Because it is the bit, and bits are basically set to 2 equal to 0 or 2 equal to 1, something like that they are set. So here the bit is being set to 2, so that's why we are doing modulo by 2, so that we could get this particular bit. So that's why we are doing modulo by 2, and we are simply adding that to our result, and then we are simply right shifting to get our next bit with us. So like this only new n would be updated, and until it gets to the last one, gets to this one. When it gets to this particular one, then it will be not equals to will become equals to 0, and then it will simply exit the loop. So like this, we will be able to count our all ones which are all bits which are being set, and thus able to return a result. And this is the second approach. Here only modifications which we are required to do is for this part, because all these parts are same only these two parts are different which we are required to do. Here we would be simply incrementing the sum, and then we will doing AND with the n minus 1, and at the end we are required to return sum. So this is how these two approaches are there, and time complexity and space complexity for both of them is equal only. So this was all for it. Thank you.